Hi everyone. Today we are going to discuss problem number 3 based on homogeneous equation. That is, in homogeneous system of equation RHS is 0. So let's see. So problem is here, solve the following system of equations. We have to given x plus y minus z plus w equal to 0. Second equation, x minus y plus 2z minus w equal to 0. Third equation, 3x plus y. Now coefficient of z is absent. That's why there is nothing will be there in place of z. So we can take here 0 also. For simplification, plus w equal to 0. So here number of equations means here I am writing now. Here m is equal to number of equation. What is the number of equation here? So number of equations means given is a 3 and you observe n is equal to number of unknowns. How many unknowns? Unknowns are, it is simply 4. Means here is a not m is equal to n, means number of rows is equal to number of column, nothing is there. But you observe very well, RHS of all the system of equations, RHS of all the equations, it 0. That's why this is what? This is a homogeneous system of equation. Homogeneous system of linear equation, guys. And we have to solve this. Now you know very well how to solve the homogeneous system of equations. So first you have to write the first step as the given equation. I am writing now, suppose here step number first. Okay, we follow step wise this example. Okay, what is step first? Write the matrix form of given system. So I am writing the matrix form of given system is, the matrix form of a given system is nothing but that is Ax is equal to Z. I am writing here A into capital X, that is equal to, what is that? Z. So where A is called as a coefficient matrix, X is unknown matrix, and Z is null matrix is there. Now I am writing matrix A. I am writing here matrix A. So let me write here matrix A. This is 3 by 3 matrix. So I am writing now in this way. Coefficient of matrix means you have to observe here coefficient of equation 1. Coefficient of equation 1 is 1, x coefficient 1, y coefficient 1, that is z coefficient -1 and w coefficient 1. So in the first column you have to write all coefficients of x. In first column you have to write all coefficient of, so I am writing here coefficient of x in first equation, so that is 1, second one is also 1, and third one is also 1. Now third one you observe here, in third equation, what is the coefficient of x is there in third equation? Coefficient of x is a 3, so I'm writing here 3. Now you observe the second coefficient of y in second column, so this will be 1, this will be -1, and this will be 1. Now you observe coefficient of z. Coefficient of z in first equation, that is a -1. In second equation, that is a 2. In third equation, z term is absent. In terms of z, or absent will be there, so that's why I am taking here 0. You can take 0, or you have to must take here 0. If any term is absent, that's coefficient you have to take 0 for simplification. And coefficient of w's in 3 equations, these are given as 1, -1, 1. So this will be 1, -1, and 1. And you have to also write now unknown matrix. So what is unknown matrix is there? Unknown matrix is x. X is called as, which are the unknowns in this equation? Which are the unknowns in this equation? X, y, z, and w, and that is equal to what, beta? That is equal to here 0, 0, and 0. That is equal to here 0, 0, and 0. So this is system of equation in a matrix form. Now I'm writing here where capital A is equal to what, capital X is equal to what, and capital Z is equal to what. So simply capital Z, it is on RHS matrix, it is called as a zero matrix, zero, or we say sometimes it is a null matrix, zero, or sometimes we say this is null matrix. Now you know again capital X is called as unknown matrix, capital X is called as unknown matrix, and capital A is called as, that is a coefficient matrix, coefficient matrix. So these are the system, is given system we have to first write in matrix form as Ax is equal to B. Okay, that is step number one. Now after the step number one, we are reduce the matrix into augmented matrix. Now augmented matrix is nothing but it is a combination of simply A and Z matrix, means LHS matrix A and RHS matrix Z is there. Now the augmented matrix of a given system, I am writing step number second here, augmented matrix. The augmented matrix of above system of equations as, this is AZ, means how to write the AZ is there. So this is just a combination of, means it is augmented matrix is a combination of matrix A and Z. I am writing now this in this way, AZ, and this is equal to, this is given by, you have to write first matrix A and combined with matrix B, right? So I am writing here the first matrix A, that is a 1 1 3 1 1 3. Second column of matrix A, 1 minus 1 1 1 minus 1 1. Third is what is that, minus 1 2 0 minus 1 2 0, and combination of matrix Z is nothing but, here is 0 matrix 0 0 0. So in this way this is your augmented matrix. Now after that you are going to step number third, that is a step third. So what we will do here in step number third, so let's see, we have to convert this augmented matrix in echelon form. Now reducing the matrix or the augmented matrix in echelon form, in echelon form. So how to convert, by using row transformation. You know the row transformation is what, we have to make operation on a row and change with respect to in matrices, that is called as a row transformation. So therefore for conversion you have to make the first row and first column leading element should be 1. So here already leading element should be 1. We have to make now below the leading element, means we have to make this is a 0 and you have to make this is a 0, means below the leading element we have to make here 0. So that's why we perform here operation. So what are the operations we'll do here, so let's see what are the operations we'll do here, let's see. So first operation you have to do in augmented matrix as R2 minus R1 comma R3 minus R1, means with the help of row R1 we make here 0 below the leading element. So we have to make change in R2, and R2 we have to make change as R2 minus here simply R1, and here is R3 minus 3 R1. So we have to take this simple row transformation, and therefore it will becomes augmented matrix is equal to, therefore augmented matrix is equal to, this is nothing will be changed in first row, means 1 1 minus 1. So let's see, there is one row is remaining in this matrices. So the row which is remaining in this matrices are 1 minus 1 1, 1 minus 1 1, and after that the all elements are 0, that is combination of matrix Z. Okay, so this is a 1 1 1 minus 1 and 1. Nothing is change in first row, and here is 0, but change in which row now? Second row. So simply it is r2 minus r1, so that you will get 1 minus 1 0, minus 1 minus 1, that you will get a minus 2. Next element 2 minus minus plus 1, that you will get 3, minus 1 minus 1, that you will get minus 2, and here is a 0. Now next we have to change in r3. R3 changes as r3 minus thrice r1, means it will get element is 0, means third row first element 0. Next we'll get here again a minus 2, we'll get again here 3, we'll get again here a minus 2, and here is a 0. You observe here, when we perform this type of operation, so row r1 and row r2 is changes is there. Now we make the row r2 and row r1 as, means below this diagonal element or diagonal element, you make diagonal element as 1. We make the diagonal element as 1, so that's why I am writing here the next row transformation. So what is the next row transformation here I am doing? So let's see. This is a minus 1 by 2 into r2, comma minus 1 by 2 into r3. This transformation we doing here. So therefore the augmented matrix of a system becomes, it can be written as augmented matrix, it can be written as this is equal to, this is now in this way. We have to write here after changing the row r2 and row r3, after changing row r2 and row r3. So this augmented matrix like now in this way, that is a first row as it is 1 1 minus 1 and 1. First row as it is, I am writing here as 0. In the second row we have to just multiply each element by minus 1 by 2. So 0 into minus 1 by 2, here is 0, minus 2 into minus 1 by 2, here is a 1, 3 into minus 1 by 2, there is a minus 3 by 2, there is a minus 3 by 2, then minus 2 into minus 1 by 2, there will be 1 is there, and here is a 0 into anything, that is a 0. Next also third row we have to multiply by minus 1 by 2, that will get 0, that will get 1, this will get again minus 3 by 2, this will get again 1, and this will get 0. Here two same rows are happening here. So where is r2 and r3? These are the two same row. So now after that, clearly you know that two rows are same here, so that's why we have to perform immediately here the row transformation, as we have to change in r3. We have to change in r3 as simply r3 minus r2 is there, r3 minus r2, and getting the augmented matrix as, so matrix az is can be written as this is now in this way. Only change in r3, so that's why first two rows as it is 1 1 minus 1 1 and 0, 1 1 minus 1 1 and 0. In a second row the element like now in this way, that is a 0 1 minus 3 by 2 1 0. Change in r3, 0 minus 0 0 means r3 minus r2, 1 minus 1 it will 0, minus 3 by 2 minus 3 by 2, that is a plus, yes, this is a minus 3 by 2 into minus of plus 3 by 2, means what is that here, minus minus plus, there will be again 0 is there, and 1 minus 1 is again 0, and this is a 0. That is in this way we have to get augmented matrix after performing the row transformation by r3 minus r2. So here clearly observe that, so this is echelon form of a matrix. This is echelon form of matrix. You clearly observe that here rank of matrix A and rank of matrix AZ means, you know, homogeneous system is always consistent, so that's why you have to check only rank of matrix A. So rank of matrix A is number of non-zero row in that matrix. So I'm writing again, also homogeneous system is always constant or always consistent. You have to check only rank of a matrix AZ, and it is nothing but it is always rank of matrix A, and it is what? It is a number of non-zero rows in echelon form of a matrix. Echelon form of a matrix. So guys, you check here only number of non-zero rows in echelon form of matrix. So how many number of non-zero rows in echelon form of matrix? There is only 2. That is a non-zero rows. So this row R1 and this row R2 will get only 2 non-zero rows are here. 2 non-zero rows. Means clearly rank of A is equal to 2. Now let me do here the next step about the rank. So we have to write the rank here. So therefore rank of matrix A is nothing but it is the rank of matrix means augmented matrix AZ, and that is equal to here number of non-zero rows. Here we have to getting 2, but now here 2 is less than n. N means what? Here number of unknowns. Number of unknowns. 2 is less than n. N means number of unknowns. So that's why I'm taking here number of unknowns. Means, you know, the number of unknowns means that is, suppose a rank we say R, and R is equal to 2, and it is less than number of unknowns, that is a 4. It is a less than number of unknowns, that is a 4. Hence system has if rank is less than n means number of unknown, then system has how many solution? It has a non-trivial solution, means it is an infinite solution. Infinite solutions means that is system has non-trivial solution. So guys, it is very easy to understanding. If system has infinitely many solution means what? It has a non-trivial solution, and we have to find out it. Now very interesting thing is here, if rank is less than number of unknown, then you have to choose number of parameter. So by using number of parameter, there is a formula. Number of parameters that is equal to it may be 4 minus 2, because of that n minus r. So simply it is what? It is n minus r. So number of parameters is equal to what we have to take in here. So 4 minus 2 is equal to 2. Two parameter is allowed. So that's why therefore 2 parameters are allowed. So that's why therefore the corresponding system of equation can be written as the corresponding system of equations can be written as. How to write the corresponding system of equations? So let's see. The augmented matrix is what? The augmented matrix means the echelon form of matrix, you know very well, that is x coefficient, y coefficient, z coefficient, and w coefficient. So by observing this, we can write the system as now in this way, that is x plus y minus z plus w equals to 0. Second one is y minus 3 by 2 into z plus w is equal to 0. There is a 2 equations are here. Because of that, only 2 non-zero rows are there. Assigning the variable z and w as, now we allowed how many parameters we have to take? two parameters. So therefore we have to put here or allows the two parameter, put here the parameters, put parameters for value of z and w, as put here z is equal to t1 and w is equal to t2. Z is equal to t1 and w is equal to t2. So therefore y is equal to, therefore y is equal to, the value of y is 3 by 2, 3 by 2 into, that is z means what is that here, t1 minus, there is a plus w means here is simply it is a t2. This is a value of y, and I have right here value of x. X is nothing but that is a minus y plus z minus w. So this can be written as x minus y means that is a 3 by 2 t1. Now this minus minus there will be plus t2 plus t1 minus t2. So therefore it will get, after calculation it will get simply it is a minus 1 divided by 2 into t1. So we got the three values as z is equal to t1 means you have to assign the two parameter. Why? Because of rank is a 2 and number of unknown is a 4. So therefore n minus r will get 2. So z as a t1, w as a t2. So you have to getting here x as 3 by 2, t1 minus t2, and you have to completely getting here, sorry, y as a 3 by 2, t1 minus t2, and x is minus 1 by 2, t1. So hence x is equal to minus 1 by 2 into t1, y is equal to 3 by 2 t1 minus t2, z is equal to t1, w is equal to t2, is non-trivial solution of, is non-trivial solution of the system where t1 and t2 are parameter, t1 and t2 are parameter. And this is example of non-homogeneous system of equation. I hope you, all of you, getting this very well and understood very easy way. Thank you.